We're going to wrap up our look at route manipulation and redistribution with a little bit of policy routing. More than a little, actually. I've got two really good labs for you here. And occasionally you'll see policy routing referred to as policy-based routing, which is the full name of it. But usually it's just called policy routing. And what we're going to do is use route maps to apply certain values to certain incoming traffic. And I realize that's not terribly specific, but it will become clear when we're actually doing the labs. Now we're going to look at some of the values you can set with policy routing in just a moment in iOS Help. But first I want to go over some of these basic rules that we will see in action during the lab. Now policy routing doesn't affect the final destination of a packet. What it really does, it affects the path the traffic takes to get there, which can include the next hop IP address. Spoiler alert. Now, policy routing can forward traffic based on the source or destination, or on the source and destination IP address with the use of an extended ACL. Now, I mention that because a lot of times you will see policy routing written strictly with a regular ACL, a non-extended, a standard, whatever you want to call it. And of course, that only matches on the source. But you can match on the source and or destination with an extended ACL. Now, if we are applying policy routing on an interface, that affects only packets arriving on that interface. And I know, thank you, Captain Obvious, but I do need to say that. Now, here's the interesting one. What about packets that are generated on the local router? If you're on router 2 and you're configuring policy routing and you have some kind of packets being generated on that router, well, that's not incoming traffic, is it? It's already inside the router when it's created. Well, what you have to do then is write what we call a local policy. And we are going to do a lab that shows you exactly how to do that and exactly how to apply it. But people miss that rule. And I missed it the first time I looked at policy routing way back when, because I thought, well, okay, I've got this down, and then I started trying to policy route some packets from the router I was on, and it wouldn't work. And it didn't work because you have policy routing and you have local policy routing. They work the same, but they're two separate operations. Now, here's the other rule. It might take you a minute or two to wrap your head around. If a packet does not match any of the specific criteria in a route map, or it does match a line that has an explicit deny statement, that data is not denied. It is denied policy routing, and what happens is it's sent to the routing process and it's processed normally. Very important rule, because of course, especially after your CCNA training, you've been working with ACLs, the second you see the word deny, your mind tends to go, okay, we're stopping traffic. Well, not in this case. What you're doing is not policy routing that particular traffic. One more rule here before we get to the lab, and that is if you don't want to route packets that don't have a match for a route map clause, what you have to do is use the set command and send those packets to the null zero interface. Then in essence you are discarding those, and of course that set command should be the final set command in the route map. Now we're going to see some of these rules in action with two labs actually paying special attention to router 4's loopback throughout the next two labs. Now let's go ahead and bring the diagram up. Might want to write this one out as we are not going to have the same screen up for the entire video. And we've got the usual links between 1 and 5 and 1, 2, and 3. We have 3110/24 between 1 and 5. Routers 1, 2, and 3 over the cloud, 172.12.123.0/24. Routers 2, 3, and 4 are also sharing an Ethernet segment, 172.12.234.0/24. And this is all one big OSPF area, and router 4 has a loopback 4444/32 that we're going to pay, as I mentioned, special attention to. And the reason is we want to trace the route that the packets are taking in certain situations. And for that, we're going to use the trace route command. We're going to start with that up on router 5. Excuse me there, I got way out of sync. There we go. So let's head over to router 5, and we're going to do a trace route on 4444. And we have connectivity. That's not the issue, because I can send simple pings. They're going to go right through. But you can see that the first hop is 3111, which from the network diagram we would expect, as frankly right now that's the only possible next hop. But what we note is that from there the packets are going down to router 2 at 123.2. That's the next hop from there. And then finally 234.4, which is router 4's Ethernet. and then pinging 4444. So checking out our diagram, that makes perfect sense. But what we want to do for our policy routing example is have those packets go to router 3 as the next hop when they leave router 1. Now the first question is, where are we going to configure this? It's really easy the first time, even if this is the very first time you've seen policy routing, you do tend to think, okay, we want to mark the traffic to as close to the source as we can. So we'll do it on router 5. But we're not going to do that because policy routing is always configured on inbound traffic. And what we're going to do is change the next hop of the traffic. So it wouldn't really behoove us to do that on router 5 because router 5 only has one possible next hop right now, and that's 3111. So let's call the equipment back up and we will get started on that. The first thing we're going to do after going over to router 1 is we have to write an ACL that is going to identify the traffic source. And since right now we're only talking traffic source, let's just go ahead and use a standard ACL. And we'll use access list 5, permit, and we'll do host 3115. So far so good. So there's our ACL. It identifies the source of the traffic we want to policy route. Now we've got to write a route map. And we can call it anything we want to. You could call it change next hop. I'm just going to call mine next hop. And then we'll do a permit, and we'll go ahead and just enter 10. Now what we want to do is match that ACL, and that's going to be match IP address 5. And now I want to set the next hop of that traffic to 172.12.123.3. And I want to show you that we have quite a few set options. We might have looked at these in another video as well, but I just wanted to show you this is why I want you to get comfortable with route maps, because you're going to be using them, and depending on what direction your career takes and of course what protocols you end up working with, especially with BGP, because you see a lot of mentions of BGP right here in iOS help. And when I put IP right here, I see a couple of changes, values I could change, not as many. But what I want to do is do a set IP next hop. And you've got a couple of different options there, but really the only one we're really interested in right now is the IP address of the next hop. That verify availability is interesting. We're not going to use that one right now. And that's it. So I've got my ACL. I have my route map that says when it matches this ACL, take this action. And now what do I need to do? I need to apply it. I'm going to apply it to the Ethernet interface because I always apply this to incoming traffic. I'm not going to apply it to serial 0 to the serial interface on router 1. I'm going to put it on the Ethernet interface on the segment that's sharing with router 5. So let's go ahead and get that done. IP policy is the command we want. You got to put in route map, even though it's the only option there. Next hop. Any other options? No. Interesting there that we didn't have any in or out options, because we've seen a couple of those. You've seen them in your NA studies. Of course, when you're applying an ACL directly to an interface, you've got to say, in or out. But again, since this is on incoming traffic only, we don't have the option of putting in or out. We don't have to. So there's one good way to test this. Let's go back to router 5 and send that trace route again. We'll send the ping just to make sure we still have connectivity, and we do. And check that out. Check out the middle hop. You can see that the policy routing is working because the next hop is 172.12.123.3 after it leaves router 1, where previously it was .2. So we have success. We've successfully applied policy routing. But, and you were just waiting on that. There's got to be a hitch to this. It's going too easy. Well, that's fine, but with the configuration we have right now, all of our traffic that we send here from router 5 is going to be policy routed, correct? Because we just put it on router 1, all traffic as long as it's sourced from 3115 is going to be policy routed. So let's run a trace route to 172.12.123.2. And that is router 2's serial interface. Note the path. Well, we've got 4 hops, if you will, 4 next hops but it shouldn't take that many. But look at the path itself. First off, of course, hop number 1, 3111. We expect that. The next hop is 123.3 because of policy routing. That's what we said. Any traffic sourced from 3115, we want to set the next hop to 123.3. Well, then router 3 gets it and says, you know, what do you want from my life? I'm connected to the 172.12.123.0 network, so I'm sending it out that interface. So you can see in line 3, it's actually sending the traffic back to 123.1. And now, as that traffic comes in, it no longer has the source address 3115. It's coming from router 3. So router 1 says, oh, okay, I'll just send it down to 123.2. And that's it. Now, the packets get there, but they don't get there in a very efficient manner. This is not a routing loop, but it is suboptimal routing. In a routing loop, the packets would never actually get there. They would just bounce back and forth between 3.1, 3.1, 3.1. Let me give you an illustrated look at that situation that we were just talking about. Pardon me. And as I mentioned here on the board, the pings from R5 at this point sent to 172.12.123.2, they're crossing our WAN 3 times. They're going across the frame 3 times. The pings get to router 1, they get policy routed down to 123.3 with what we did, set IP next hop. R3 sees the packets are destined for 123.2, and of course it sends it right back to router 1 saying, okay, we're on that network, it's connected, so here are your packets back. And then router 1 gets them. They no longer have the source IP that matches that ACL, so the packets are then routed normally to R2. So again, I know I told you this twice, but I wanted to give you the illustrated explanation as well as the explanation on the live equipment. And this is why so often in policy routing you're going to see extended ACLs used rather than standard. Because sometimes, like in this situation, we want certain traffic coming from router 5 to be policy routed instead of what we're doing right now, which is, hey, every bit of traffic from router 5 is going to then have the next hop IP address 123.3 when it leaves router 1. You probably don't want that, and in this instance we certainly don't. So what we will do in the beginning of the very next video is remove some of what we've done to this point, actually all of it, because we want to take the ACL off too. And then we're going to run this lab with an extended ACL, so when policy routing takes place on router 1, certain traffic will be policy routed and certain traffic will not. So to catch your breath, and I'll see you on the next vid.